In this problem, we are asked to find the amplitude, the period, and the phase shift, and sketch the graph of the function y is equal to sine of 2x minus pi plus 1. We will recognize that adding 1 at the end of our function is going to shift the entire graph up 1 unit. In order to solve this problem, let's first investigate its parent function, y is equal to the sine of 2x minus pi. We will first graph the 5 critical points for sine, 3 x-intercepts in the high and low point, and then we will shift the entire graph up by 1 unit by adding 1 to each one of the output values. We will recognize in the function y is equal to sine of 2x minus 1 that our amplitude is equal to 1, b is equal to 2, which gives our period of both functions to be 2 pi over 2, or pi units. 1 full cycle in our phase shift can be expressed as the opposite of c over b. In this case, it would be the opposite of a negative pi, or pi over 2, and our cycle interval going between 2 pi and 0. If we add pi to both sides and divide by 2, we will see that our one cycle interval goes from pi over 2 to 3 pi over 2, giving us a period of pi units. We will now sketch a 1 full cycle of y equal to sine of 2x minus pi, still knowing that we have to take care of the vertical shift. We will put our scale down, pi over 2, 2 pi over 2, which is pi, and 3 pi over 2. We know in y is equal to sine of 2x minus pi that our x-intercepts start and stop our interval. Our other x-intercept lies halfway between that start and stop of that interval, giving us those 2 points. We will also notice that our function sine equal to, or y equal to the sine of 2x minus 1 takes on its maximum value halfway between pi over 2 and pi, which is 3 pi over 4. And it takes its minimum value of negative 1 halfway between pi and 3 pi over 2, which is given by 5 pi over 4. We are now ready to shift each point up 1 unit. This point at pi over 2, 0, would now move up 1 unit and would be at pi over 2, 1. The maximum value at 3 pi over 4, producing a y value of 1 in our original equation, would also be moved up 1. Continuing this process by increasing each value by 1, we will get a graph of our vertical shift. We might want to know what is the value of our y-intercept, so we could figure out when x is equal to 0, what's the value of y. This is given by the sine of 2 times 0 minus pi plus 1. As we are working, 2 times 0 is 0, so this is the sine of a negative pi plus 1. Sine of negative pi produces 0, so this will also be equal to 1. This makes sense because if we continue in this function at pi over 4, it would go back to 0, and then it starts increasing again until it hits its y-intercept at 0, 1.